In 3.3, we're going to look at two other rules for finding derivatives. 3.3 is not on your exam 1, but you're free to use these rules if you wish. So the first one we're going to do is we're going to look at the product rule. Now, whenever you're taking the derivative of two functions that you're multiplying, then the product rule says you take the derivative of the first times, keep the second, plus keep the first times the derivative of the second function. The other rule we're going to look at is the quotient rule. So the quotient rule is when you're taking the derivative of a fraction of two functions. That's a little bit more complicated. So if I look at the top piece, f, I'll call that h for the higher function, and I'll call g L for the lower function. Then the derivative is the lower function times the derivative of the higher function minus the higher function times the derivative of the lower function divided by the lower function squared. So it's actually very musical. It's low d high minus high d low over the lower squared. In example 1a, we have the product of two functions. Now we could multiply all this out as we did in 3.2, but instead let me use the product rule. The derivative of this function is going to be, we take the derivative of the first piece, x squared minus 3, and we're going to multiply it by the second function, x to the fourth minus x plus 1. Plus, since we're using the product rule, keep the first, which is x squared minus 3, times the derivative of the second. Okay, so let's go ahead and simplify this. The derivative of x squared minus 3 is 2x, and times x to the fourth minus x plus 1 plus x squared minus 3 times the derivative of x to the fourth minus x plus 1 is 4x to the third minus 1. Now at this point I would have to multiply all this out and combine like terms to get 2x to the fifth minus 2x squared plus 2x plus 4x to the fifth minus x squared minus 12x to the third plus 3. When I combine my like terms, I end up with 6x to the fifth minus 12x to the third minus 3x squared plus 2x plus 3. So it's still pretty long. So that's a personal preference, multiplying everything out in the beginning or using the product rule to find the derivative. Now let's look at an example where we use the quotient rule. So notice in part B, we have a fraction of two functions of x. So when I compute the derivative, it's going to be equal to low d high minus high d low. So the lower function is x squared minus 5, and then I would take the derivative of the upper function, 3x plus 1, minus the higher function, 3x plus 1, times the derivative of the lower function, x squared minus 5. So again, that's low d high, high d low. And then we take the x squared minus 5, the lower function, squared. Now it's just a matter of simplifying this and taking the derivative of those smaller pieces. I have x squared minus 5 times 3 minus 3x plus 1 times 2x over x squared minus 5 squared. In the numerator we have 3x squared minus 15. This would be minus 6x squared minus 2x. Now the last step is to check to see if we can factor and cancel, but it doesn't look like we can. This is going to be a negative 3x squared minus 2x minus 15. So even if I could factor that numerator out, it's not going to cancel with anything in the denominator. And this would be the derivative of f using the quotient rule. Let's look at a few more examples. In part C, this is the quotient rule. However, notice that in the denominator I just have an x squared. So if you would like, you can also use the product rule, because this is the same as x to the 4th plus 2x minus 1 in parentheses times x to the negative 2 if I were to bring that x squared up. So you can use the product rule here as well. I'm just going to go ahead and use the quotient rule. The derivative is going to be low d high, so x squared times the derivative, and here I'm not going to write the derivative now, I'm just going to compute the derivative, which would be the derivative of the higher function would be 4x to the 3rd plus, oops, sorry, this is supposed to be a 3. 4x to the 3rd plus 2 minus x to the 4th plus 2x minus 1 times the derivative of x squared, which is just 2x, all over x squared squared, which would be x to the 4th. And then now let's go ahead and see what happens in the numerator. Maybe things will cancel. I have 4x to the 5th plus 2x squared minus 2x to the 5th minus 4x plus 2x. Oh, sorry, 4x squared plus 2x. And that would be all over x to the 4th. And combining our like terms, I have 2x to the 5th minus 2x squared plus 2x. So notice that I could factor a common x out and cancel everything by x's to simplify this, or I could simply divide each term by x to the 4th and separate this. So it'd be 2x minus 2 over x squared plus 2 over x to the 3rd. Our last example would be if you need to combine the product rule with the quotient rule. in example 2, notice I'm trying to find the derivative. Now, normally what I would do is I would go ahead and multiply this numerator out to have x squared minus 3x plus 2 over x minus 3. And then I would use the quotient rule. But just for the sake of argument, I'm going to leave it exactly as I see it. I'm going to use this form. And this would be by the quotient rule. So it's low d high, low. The derivative, and this time I am going to write this out, because the derivative in this case is going to be the product rule, because it's x minus 1 times x minus 2 minus x minus 1, x minus 2, derivative with respect to x of the denominator, x minus 3. So that would be low d high minus high d low, all over the denominator squared, so x minus 3 squared. In the numerator, when I take the derivative, I'm going to need to use the product rule. So remember, that's going to be the derivative of x minus 1, which is just 1, keep the x minus 2, plus keep x minus 1, and the derivative of x minus 2 is just 1. Let me go ahead and multiply the x minus 1 times x minus 2 out to be x squared minus 3x plus 2. And then the derivative of x minus 3 is simply 1. Now it's just a matter of simplifying and see if anything cancels. In the numerator, this is going to be x minus 3. And these 1's don't change anything on the product. So this is going to be 2x minus 3. Minus, again, the 1 doesn't do anything with the product, minus x squared plus 3x minus 2. And then I would have to multiply out those binomials. I doubt if anything's going to cancel though. To get 2x squared minus 3 minus 6 would turn into a, well, I'll write it out, minus 6x minus 3x plus 9 minus x squared plus 3x minus 2. Alright, so it looks like I'm going to end up with x squared minus 6x plus 7. Even if that did factor, it's not going to cancel with anything in the denominator, so this would be my derivative y prime. So just to backtrack, although I could use a combination of quotient and product rule, in this particular case, I would rather multiply that numerator out and just use the quotient rule. Oops. Okay, so that's it for this section.